Obviously it was in Rocky. It's the Rocky Steps. There's a lot of history behind it. There's also history inside of it. And honestly, I love the Roman pillars out front. It's just a big, grand building, kind of right like off to the side of the heart of the city. Like all roads kind of lead there. And honestly, it'll always be a personal favorite because that's where I proposed to my wife. So it was kind of
Oh,
the start of our story. And at the time it had the love sign is down the street, but then they had one up on top there. So I proposed right in front of that, and it was a really beautiful night. I mean, it's just a beautiful scene there. So that's my favorite.
that's so sweet. We love buildings that have meaning for us as well. And I love also how James talked about the location of where the building is, the specific location, and why it really works for that specific location, which is something we're going to talk about with the challenge tonight as well. So I think I'm going to get started with the formal presentation. Things are getting really exciting. So welcome. If you're just joining us, this is the Make It Big webinar series. We're already on episode 3 as well. So this is a webinar series that's also associated with a series of design challenges. And one of those challenges, the second challenge we're going to be announcing tonight as well. So these challenges are actually inspired by football star James Develin, who you just heard from, in a real life design and construction project that he is working on right now. So we are so happy that you're here. We're already halfway through the series as well. So this is episode 3, Make It Work. And we're going to talk about what that means and the significance to the contest tonight as well. So again, we want to keep this as engaging and as participatory as possible, but we want to do so within the constraints of making sure that as students that your privacy is kept safe. So you will notice at the bottom of your screen, there are 3 icons. So there's the chat icon, the raise hand icon, and the question and answer icon. You'll notice the chat is somewhat disabled. You may not chat with other participants tonight. And again, that's to protect your privacy, but you may chat with us as well. And so you will be chatting when you do chat with real humans. In this case, it's the adult human in this photo, Matthew Dalton, who's the community manager for Autodesk Education. So if during tonight's presentation, if you have some like quick questions that you want to ask, or maybe you just have some commentary that you want to share with Matthew, or also with Donald Bell, who manages marketing and communications for Autodesk Education. They'll be there and they are a wealth of information for you. So please, feel free to chat with them throughout the episode. We also have a AutoCAD expert in the chat helping tonight, Kayla, who's our special guest too. And you've already heard from Jenny. So Jenny Fennell is the content development manager for Autodesk Education. With each segment tonight, we will be asking you a question that you can answer, kind of similar to the warm-up question and the question and answer. And periodically throughout the episode, Jenny is going to kind of chime in so that we can hear your voices as part of the episode tonight too. I'm also so excited that we have Zakia Grant, who is the program manager for EcoRise, which is an awesome curriculum that teaches students about sustainable design and green building. She's also a lead green associate as well, which is a great certification that you could aspire to also as a student. And I'm also very excited that we're joined by Dan Whitcomb tonight, who is a product manager for Autocad. So we're going to learn a little bit more about Autocad tonight too. And Autocad is part of the Autodesk family. I think it is the forefather of Autodesk. So I just want to introduce myself as well. My name is Kellyanne Mahoney. I am a youth program specialist for Autodesk. I'm based in Boston. I used to be a teacher, but I have been working at Autodesk. This is my 4th year here. I'm not as interesting as Heather Lech, who's also here tonight. You want to say hi and introduce yourself as well?
Yeah, hi everyone. I'm Heather and I'm a product manager here at Autodesk. I'm also a licensed architect by training, and then I transitioned to be working and building software for the architecture and engineering and construction industry. And I'm also in the Boston office with Kellyanne, and I have been with Autodesk for about 15 years now. So welcome, and I look forward to showing you a little bit more about FormIt in a few minutes.
So cool. Thank you, Heather. And it's just part of this series also is we would like to expose you to interesting career paths like Heather, where she went from architecture into software, into product management. So cool and so happy to have you here, Heather. Last but not least, I want to introduce again football star James Develin, three-time Super Bowl champion. He played on the New England Patriots for a number of years. So James, do you want to just say hi again and introduce yourself, I guess,
Sure.
a little more than I just did.
Hi, everyone. I'm James Develin. Thanks for tuning in here tonight. Yes, I played for the New England Patriots for 8 years, 2 years before that with the Cincinnati Bengals. Recently retired in 2020. So now I'm just kind of embarking on an entrepreneurial journey, and I've been lucky enough to partner up with Autodesk to kind of formulate this series and really kind of provide some challenges and some contests and promote the STEM world. So I look forward to seeing what you guys can come up with in these challenges and really just do some great things. So.
Well, thank you, James. You've been a wonderful inspiration to all of us. We're also going to see some of the entries from the last contest, and James is going to share those with us. And James, has a passion for sports, has a passion for architecture, and it's just really cool how he's able to kind of blend those passions together into this new project. So we are so glad to have him here. And we're glad to have you here, students, and we hope that you take away some learning from this episode. So one of the things that we want you to do as a result of this episode is to learn sustainable strategies to drive design through using tools like Tinkercad, FormIt, and Autocad. We also hope that through the challenge, if you choose to engage in the challenge, and we hope that you do, that you'll be able to apply technical skills and engineering mindset and computational thinking to help James make his design work. And lastly, we hope that you compete in all 3 of the challenges. And if you didn't compete the last time, it's totally fine. You can jump in right now too and still develop a beautiful digital portfolio that could also earn you a chance to win prizes. So we'll talk about prizes later too. So this series is kind of a journey through architecture, engineering, into construction. So this is episode 3. If you missed the first 2 episodes, the first contest, no worries. This is a fine time to join in, and you can also catch up on the recordings of earlier episodes, and I'll show you how you can do that later. Right now, we're actually kind of entering into kind of more of an engineering mindset. So very excited about the challenge, and also we'll have another webinar next month that is focused even more specifically on engineering. So the game plan for tonight, so we're going to hear some highlights and analysis with James, primarily based on the entries from the last contest and how students' ideas are really inspiring him for the development of his own real life project that he's working on right now. I'm going to talk to you a little bit about how you can make it work for this contest with Tinkercad. And we also will be joined by our lovely guest, Zakia from EcoRise, and she's going to share with you a really cool project that you might be able to incorporate into your design about living walls. We're going to then next hear from Heather, who's going to talk about solar and energy analysis and also computational design within FormIt. We're going to hear from Dan, who's going to talk to us about landscape design with AutoCAD. And then lastly, we're going to talk about Make It Big Again, the competition, the Student Design Challenge, and how all of what you're learning tonight relates to the newest competition. So just really quickly, if you're just joining us now, so we are Autodesk. So Autodesk makes software for people who make things. So if you've ever driven in or admired a smart car, an electric car, high performance vehicle, if you've stood in awe at a skyscraper, I know I have before, or marveled at the engineering of infrastructure like a bridge, or you've delighted in a blockbuster film or a video game, chances are you've engaged with something that one of our customers has made. And when we talk about things like the future of construction or even like the future of engineering, we're not just talking about like drones and robots and machine learning and sensors. We're also talking about you as students. We really do see you as the future of all of these industries. And because of that, that's one reason why we do make a lot of the tools that our professional customers use free to use. So there's about 100 of them that both you as students and also your teachers as educators have access to for free. So that was something that I just wanted to make clear, that everything that we're showing to you tonight, you should be able to get free access to as a student or as a teacher. So next up, we have highlights and analysis with James. So I'm going to pass over the mic to James. I just wanted to share, this is one of my favorite details from the Autodesk Make It Real first competition. And this is one of the runners up as well. So she added this lovely detail to her building that she made at Tinkercad. I thought James would appreciate it.
Looks exactly like me when I take my hat off. But thankfully,
so
I'm always wearing a hat. So
but that's a new challenge. So before James gets started, I just want to let you know that the question at the end of this segment is, what do you like most about the winning designs and what could be improved? So you could let us know about this in the question and answer as you're listening to James. So I'm really legitimately going to pass the mic to James now. So there you are.
All right. Thank you, Kellyanne. Yes, again, I'm James Develin, and thanks for joining tonight. And really, first and foremost, I just want to formally, congratulate and thank all the 67 entries that we got on the first challenge. I've periodically just flipped through them and really just read through each one. And it's been an absolutely, eye-opening experience to see some of the, just innovative ways of doing things and of designing this building. So I will share my screen here and we'll take a look at a few of them. So it was, I was blown away at some of the submittals, and really I had a few of my favorites, and I started to work some of their ideas into my own design going forward. The 3 grand prize winners, Theophile S, Josiah Miller, and I believe this is Cooper N4. You can't see it here, but just absolutely awesome work. In particular, I loved the idea with the track on the roof here, and then the long sets of stairs. That was something that I mentioned in the beginning, in the first webinar. I'm sorry, and about the cascade of stairs to kind of provide another, another way of working out, just climbing stairs with weights or something like that. But also, it obviously serves a purpose to getting to different floors and things like that. The setups, and I was blown away at some of the ideas that you guys provided. The beautiful architecture on this one. There's a little bit of a integration into living walls, which I'm sure we'll get to later. Like right here, and it was just, so I was just really impressed with all the ideas, and just look how beautiful this building is, and just all the thought that went into it. Each, every piece of equipment is accounted for. The cold plunge pools, the hot tub, the swimming lanes. There was nothing left out, but even room for a field here. I got to tip the cap to, I'm not exactly sure how to pronounce this, Heschalier, maybe. But he correctly predicted where I was going to put this. He's from my area, Philadelphia, and that the location of this design is something that it's really been racking through my brain lately. And he actually chose Conshohocken, Pennsylvania, and really Plymouth Meeting, which is all in the same area. I actually used to live in Plymouth Meeting, and I'm now moving back, and so that's actually where I'd really like to put this facility once all is said and done. But that kind of brings me to where I am in my project. Started developing like a prototype gym space here, in working in FormIt, and just kind of trying to take in some of the ideas that you guys provided, the long sets of staircase, the second level track to kind of get it up and out of the way, big field house. I was going to do, so all the rehab and cold tubs in this room area. And, this is in Conshohocken, Pennsylvania. This is obviously where I said I wanted to put it. But so far I've had some difficulties in really locking down a location. and I'm trying to figure out what's my best move here, trying to kind of work on this engineering type mindset where I have this problem. I have to find the location that works for me. Where can I, service the most people? What's the most accessible, for people coming from all towns and counties in the area. And Conshohocken, the King of Prussia area in Philadelphia, I know that a lot of people aren't familiar with it, but it's kind of at the hub of the suburbs. Every major highway kind of converges right there. So it's very accessible for people from really all around. And there's a lot of pretty big facilities there. It's Conshohocken has a railroad that goes right through. So there's a lot of warehouses down on that railroad. This exact property is actually just a few right behind this dirt pile. There's a railroad. So this, yeah, I mean, this is where I'm at right now. I'm trying to lock down a location that really suits my needs. Whether I buy an existing building and rehab it if it works, or do I just get land and start from scratch, and then I can kind of have my pick. But obviously there's costs that kind of inflate, and pros and cons to both. So I'm just kind of figuring that out now. And in doing so, I'm hoping that you guys can really come up with some more genius ideas and some more innovative ways to do things better. To think of environmental sustainability, and what Heather's going to go through a little later in FormIt. It's a great tool for using, for looking into how the sun affects your building, the natural light, where does that come over in all different days of the year? Is there an opportunity for a large building like this to have a great, roof area that you can get solar panels on and really, provide a lot of energy that way? And, and then obviously just being accessible for the people that I'm trying to service, people with disabilities, or on crutches and wheelchairs and stuff like that. I mean, those are the type of people that we want in this facility to rehab and make them better. And so I have to keep that in mind and keep it all going forward. I touched on, this is in Conshohocken, Pennsylvania. This exact building is on Conshohocken State Road. It has a turf space in the back. It's used to be an athletic field in there. So it's actually already kind of set up exactly how I'm drawing it. And, and then I just wanted to, think of different ways as an entrepreneur to kind of, how am I going to provide my services as best I can to the community? Obviously I want a great big location like this, but location seems to be my biggest hurdle right now. And, so I've been thinking of different ways to try to, get that community outreach going. And, one of my ideas was, why don't I put a gym on a truck, like make like a modular vehicle that I can just kind of, fold, racks and rigs off the sides, and maybe store some more portable gym equipment inside the truck, and be able to take it right to the people that I'm trying to help. So just thinking of ideas, just trying to, obviously problem solve, and coming up with things all the time that, little hiccups and hurdles that I find, and just trying to make my way over it. And that's honestly the engineering mindset in a nutshell. Is just trying to figure out ways to do things better. So hoping that you guys can come up with some great ideas and show me some new ways to think about these problems.
Awesome, James. And I'm already seeing some suggestions in the comments as well. So you have really wonderful design partners and the students who are continuing to partner with you. And we really appreciate your creativity and your innovation, and really thinking about, community needs, which is really essential to this design challenge, which I'm going to share next. We do that. I just wanted to ask Jenny if there were any comments in the question and answer about what students like the most about the designs that James featured, and maybe even some ideas of how they could be improved. Again, thinking about that engineering mindset where we are not only problem solving, but also problem finding.
I'm not seeing comments yet around this question. Let me check back.
Well, James did a wonderful job with his analysis, and for the sake of time, I'm going to keep moving on. All right, so next up, we're going to talk about how to make it work with Tinkercad and EcoRise. So again, in thinking like an architect, you're oftentimes mitigating different trade-offs like noise and sound and natural light and adjacency to different spaces, variety, views, profit, cost. But the essence of this challenge that we're about to introduce is that some things should never be trade-offs. So things like what James was talking about, accessibility for people with disabilities, and also environmental sustainability. And that is the essence of the challenge, where we're asking you to, again, to use an engineering mindset and computational thinking to help James make his vision work for the environment, the surrounding community, and for people with disabilities. So as I'm talking about the new challenge, do please let us know in the question and answer what questions you have about the new challenge, and Jenny might be able to share some of those questions at the end of this segment. So why are we talking about this? Well, we're asking, one of the criterion for the competition that judges are going to be thinking about this time is your ability to use computational thinking to help James solve his problem. So what is computational thinking? This is it in a nutshell. It's decomposition, it's abstraction, it's pattern recognition, and it's algorithms. And it's also kind of like a mindset. And once I explain these things a little bit, I think that you might realize that you're already doing these things already just in your day-to-day life, and that computational thinking doesn't even require a computer to do. So what does it look like in the context of making, for example? So here's an example of decomposition. When you're decomposing, you're basically kind of taking something apart to figure it out. It's like a reverse engineering process. This is an example from Dr. Natrice Gaskins, who's a maker educator and also an artist as well. And she uses Tinkercad in some of her public art projects. And sometimes when she designs things to kind of iterate and come up with imaginative ideas in Tinkercad, and she has a 3D design, but then she needs to actually translate that 3D design into something that's two-dimensional. So taking something 3D and transforming it into something 2D because of the manner in which she's fabricating it, for example. So for example, with this shape, she actually wanted to laser cut it. So she had to actually make it flat. So that's an example of decomposition. So another one is pattern recognition. Pattern recognition is you're taking something big and complex, like something like a building, and you're looking for similarities across things, so certain patterns, is in order to come up with a more simplified process for understanding it. So abstraction is also just thinking about, so you're trying to figure out the essence of a thing, really thinking about its key details or key components. And once you do so, you can kind of refine it down to its simplest kind of essence. And in doing that, you can then start iterating on it and try to, maybe even come up with a new innovative thing. And lastly is algorithms. So once you've kind of come up with that idea for the thing or the essence of the thing, you might want to figure out how to make the thing, or how could you use an automated process in order to make the thing. Algorithms are just step-by-step instructions for making something, for example, that are so easy that even a robot could follow it. So that's computational thinking, and you can practice computational thinking within Tinkercad. So one of the environments within Tinkercad is Tinkercad Codeblocks. If you're unfamiliar with Tinkercad, please go back to episode 1 of this series where I do kind of a more detailed explanation of what is Tinkercad. But this is Tinkercad Codeblocks. Tinkercad Codeblocks allows you to practice computational thinking. Coding, just like design, is a process. So you're just starting by making decisions. So you might make a decision about, stacking, shapes or blocks, running them, reviewing them, and then trying again. So similar to other processes like writing, for example, its failure is built in as part of the process. And that's one of the things that I really love about coding and computational thinking. So if you want to play with Tinkercad Codeblocks, or maybe you want to start out a design in Tinkercad Codeblocks and practice your computational thinking there, this is how you get in. So there are 3 environments within Tinkercad. There's the 3D editor, there's the circuits editor, and there's Codeblocks. So once you choose Codeblocks, you'll open up a mini dashboard that is 3 activities that are self-directed, that are quick and easy, and they're meant to just help you kind of teach yourself the basic moves within Codeblocks. Codeblocks is a computational design workspace. It's the simplest place to make 3D models using draggable blocks of code. So for example, if you've ever used Scratch before, it's the similar or the same block, Scratch blocks, that one would use in Scratch as well. The way that I actually taught myself how to design in Tinkercad Codeblocks was by analyzing the designs of other users. So you can see also in this mini dashboard that there are starter designs that you can go in and look at the code for how the designer made them. So this is just the user interface. So you have your blocks panel on the left, the blocks editor in the middle, and the 3D viewer on the right. And really what you're doing is just dragging and dropping your shapes onto the blocks editor. And then really quickly you can start to change those shapes. So you can turn the color from red to green. And you can see what I'm doing there is clicking that play button at the top. And that's going to help you when you're kind of going through this process of thinking, well, I'm trying to tell the code to make this thing, and I want it to be green, for example, but I'm going to hit play and I'm going to see if it actually does what I wanted it to do. And if it didn't, it's fine. You can go back and fiddle with the code again and play again, and eventually you'll get it right. Another way that you can inspect your design in Codeblocks is just when you go into the 3D viewer. You can zoom in, you can zoom out, but there's also the view cube that's the same that you would see in the 3D editor is also in Codeblocks. So that's kind of like a mini controller for your design that also helps you to zoom in and zoom out and really makes the designing accessible. So you can also within Codeblocks change the size of the shape. So you can see that I clicked on that arrow and it opened up a drawer that gave me kind of more parameters or more flexibility to play with the design. So I'm changing the shape there really quickly. Another really exciting element to Codeblocks is it really helps you. If you've ever asked your math teacher before, what's the point of learning the Cartesian coordinate system? Well, now you have an answer. So the fun part about Codeblocks is it's built upon, so when you're designing, you're perhaps moving a shape across the X axis or the Y axis. But we also have the Z axis as well. So that is maybe something new to you if you've done block space coding before, that you can actually design and play along the Z axis, which is actually what makes your design 3-dimensional. So that's an example here. And you're just kind of moving your shape along kind of step by step along a path. And last but not least, I wanted to share Matthew Dalton made this awesome design that I think could be an inspiration for you in thinking about how could I incorporate Codeblocks into my design. So as you see here, once you get really good at Codeblocks, like Matthew Dalton is, you can see that he's written this script. And this script is meant to be a recipe for making stairs in Tinkercad. So you'll see once I play it, they build really quickly. So that's cool in and of itself. But one of the things that I found the most cool about this design is that it's adjustable. And the reason why it's so playful and so adjustable and so flexible is because he built in variables at the top of his code. So you'll see here that if I change the step width and make it 40, and then also change the number of landings to 3, and then if I play the design again or run the code again, you'll see that it just changes like right away automatically. And this is actually one of the things that we're going to show you with Heather's FormIt design is within FormIt, there's also out of the box scripts from Dynamo that she's going to talk about. And one of the things that one of our teacher friends actually said to us is students should know that automation isn't a naturally occurring process. It's actually something that someone creates, so it's the stairs didn't come out of nowhere. Matthew thought about what is the step-by-step instructions for making these stairs. So you can move from Codeblocks into the 3D editor, and you can take the design that you made in Codeblocks and turn it into a part, just like this, and then you can bring it into the 3D editor. So you can keep your script for your stairs in your pocket, and then you can keep changing it and then turning it into different parts of different sizes. So just lastly, I wanted to talk a little bit about thinking like an engineer. And this is kind of lining up Sakia's presentation, which is wonderful, about living walls. And how you can, in thinking about particularly the environmental sustainability question that James has for us, how can you take on some of these habits of mind of an engineer? And also just think about how they already relate to some of the ways that you're already thinking, your curiosity and your open-mindedness. And this is also just meant for you, and we'll be sharing these slides with you later. So to show your engineering mindset, you might be thinking about what are the criteria that James is talking about, thinking about James as your client. So what are the, the most essential elements or the most positive features of the design? And also what are some constraints? So you might have technical constraints, you might have sustainability constraints or market constraints. So I do encourage you students that are competing in the competition to think about these questions and go back to these questions. And you'll have some access to them through the slideshow. So next up, I'm so excited to introduce Sakia Grant, again, program manager at EcoRise and lead green associate. And she's going to talk to us a little bit about living walls.
Thank you, Kellyanne, and I'm grateful to be part of this panel, and thank you, James, for coming up with these wonderful challenges for students and thinking about sustainability in the challenge. And so sustainability is important, especially when we talk about adding to the built environment. We want to make sure that we are including things that are not harmful to the environment and also beneficial for people's well-being. You can go to the next slide, thanks. So I'm just going to touch upon this very briefly about the sustainable development goals. And they're a global blueprint to achieve a better and more sustainable future for everyone around the globe. And a lot of times when we think about the UN that puts out these SDGs, we think about other places, and these SDGs are very relevant to where we are right now. And as you can see, when we're thinking about building a sustainable community, things such as good health and well-being are on there. And obviously things like sustainable cities and communities and clean water. But the idea that your health and your well-being is important is a great addition to this. And having a gym that caters to that definitely is part of solving those sustainability inequities and part of getting us to that better and more sustainable future for all. So adding a living wall definitely will get some points on your sustainability in your building, but what exactly is a living wall? And a living wall is just a wall that's partially or completely covered with vegetation and a growing medium for their plants to survive, and depending on its sophistication, an integrated watering system. And so as you can see here on the left-hand side, there's something that's really simple, made out of some recyclable material, which is a pallet. And then on the right-hand side, we have something that's a little bit more structured. These can become even more elaborate. They can be indoor or outdoor, and I have some more examples as we move along. So we'll touch upon all these things that living walls can do for your building, such as reducing air pollution, how it impacts water, energy, and improving the aesthetic quality of the community. And so before we get into all of those other three, I do want to stress that having that aesthetic quality is important. You know, how seeing plants or anything that resembles the outdoors, especially like it's wintertime in our area, and we don't have a lot of green right now. And so there are some issues that come with not seeing lots of trees and shrubbery and all that stuff. So if you can incorporate that into your building, people may be more interested in going to that building, caring about their health. So having that in there and improving the aesthetic quality of the community is very, very important, and goes back to that kind of like that health and well-being and putting people in a great mental space. So besides all the nice looking things, our living walls definitely have some very good climate change qualities. And so filtering out pollutants, producing oxygen, and all that good stuff so that we have clean air to breathe. And you can read through all the details on these slides once we have the recording up later. So I'm just going to go through some of the basic things very quickly. Saving water. So if you use using a gray water system in your building, you can use that gray water to water your plants. Gray water usually comes from certain things that don't have contact with human waste. So any other water that just maybe has, you know, other things in it, but not human waste, you can use to water your plants. Also rainwater. It can also prevent extra water from running off and causing flooding. It can regulate temperatures so that you're saving energy, whether you're saving heat energy or you're saving for running the AC in the summertime. And so now we're going to go over a couple of living wall example designs, and they can range from very simple to very elaborate. So if you want to talk about getting into the aesthetics and choosing certain plants that give you a really cool design, you can do that. And then you can get into the types of systems where the plants are actually being held, and how simple or complex that can be. So as you can see on the left-hand side, you have more of a connected bucket system that might be PVC or some other type of material. Whereas on the right-hand side, kind of looks like some, you know, regular planter pots from any garden store, just hung on kind of like caging or fencing. And then the next designs are kind of the same thing. You can also think about having your living wall do some double duty, having it to grow food, which also gets into the health, the health component of sustainability. So how do these things actually get constructed, right? There's a couple of different ways. You can choose from a few different different ways, and this is by no means complete. There are probably many different ways that you can construct a living wall, but you can use a modular system, which basically means that you have pieces. And so these can be attached to a wall, similar to maybe that like first picture that we saw that as a palette, but a little bit more complex. And so that you could use that if you want to decide that you want to have a split in an irrigation system. You would have these put to a wall. You definitely need waterproofing for your wall, because you don't want your drywall to absorb any water from the plants and start to rot or mold. That's very, very important. Or you can have a complete hydroponic system. And so with that, the hydroponic system, you'll have to have a growing medium that is not necessarily soil. You can use felt and have that hydroponic system run through the wall. You'll, again, definitely need waterproofing for that when you attach it to the drywall. Or you can have that simple cable and wire system. And so the cable and wire system might be easier, but it also might require some more maintenance unless you put in another irrigation system, and that's not connected to a wall. So you would definitely need special felt. It's not the felt that you use for for clothing. There is a special growing plant felt. So you definitely need to know how your plants are going to get watered, because if your plants are not living, you do not have a living wall. So you have to decide whether you're going to have a recirculating irrigation, where you're constantly reusing water once you input it into the system once. And again, you'll have to account for some loss due to transpiration, or a direct irrigation system, where you're bringing the water in, and it's going to go out and not be used, right? And you may decide to use that direct irrigation system for for a specific reason. You know, it seems like it would be more sustainable to use the recirculating irrigation, but different systems require different inputs and outputs. We talked about growing medium. It can be soil, but again, there are pros and cons with using soil. You can use felt. You can use things like rock wool. They use that in hydroponics a lot. So there's different pros and cons for each of them, mainly weight and load. And then you have to decide what type of plants that you want to use. So there are plants that survive on a living wall outside, but may not be best inside. You have to think about what your weather is like, and what your plant is going to weigh when it's fully grown. So lots of different plant characteristics that you need to take consideration. And again, you want to make sure that these plants are not weighing down a wall to have it collapse. So if you need some help kind of thinking about what your design of a living wall would be, such as what plants you want, what kind of design that you would like, what kind of irrigation system you would want to include, we have a guide that will help you through that process, so that when you get to some of the other things like FormIt, you already know what you want to put on and how it's going to look like. You can go to that link that's being put in the chat, and you'll be able to get to our design guide. And teachers, guardians, and parents, if you're interested in more sustainability curriculum, and including the full lesson plan to the living wall exercise, you can visit the link that's being provided in the chat, and you will be able to sign up and get some free sustainability curriculum resources for Massachusetts teachers, because I know we do have some teachers on with us. If you enroll with your school district email, I'll be able to capture your email and direct you to some even more free resources, such as our entire sustainability curriculum. So please make sure you do enroll in your with your school email as a teacher.
That is such a gracious, wonderful offer, Zakia. We really appreciate it. And I'm already thinking about where can I build a living wall in my house? So always inspiring, and really excited to see some of the students' ideas for maybe incorporating a living wall or other landscaping in order to make their design more sustainable. So thank you, Zakia. So before we move on to the next segment, I'm just wondering, Jenny, did we have any questions about the new challenge and the question and answer?
Yeah, we do have one question. I have a group of 5 students who want to work on this. Should I separate them or have them work together?
I mean, I think it's your decision as a teacher in terms of how you want to organize it. The way that so there are 13 prizes, 3 grand prizes. So it would be, for each project, it's 1 prize. So just kind of think about it that way as well. And you can also email me at makeitreal@autodesk.com because I can answer teacher specific questions as well. But that's a really good one. And I would say that that's a teacher decision, but just kind of think about if you win the prize, how you're going to mitigate that. Other questions, Jenny?
We don't have any others. Oh, yeah, there is one. Well, where are we enrolling for the link? So someone's asking for the link. So we'll put that in the chat.
Yeah, and I'll also show you the new contest page as well. And I'm sure that someone can put that in the chat as well too. And that's where you can find even more details about the contest. So up next, we're going to hear from Heather, who's going to talk about solar and energy analysis and computational design within FormIt. And she's also going to just start to talk about a little bit, as James had shared, a lot of students' designs were actually done in Tinkercad. So she just wanted to talk a little bit about if you wanted to take your design from Tinkercad and move it into FormIt to use some of these new tools that she's sharing with you today. She's going to talk a little bit about that now. So Heather, take it away.
Thanks, Kellyanne. Yeah, so this is an image of a model that was done inside of Tinkercad, and then it was exported from Tinkercad, and you can choose a .obj file when you export it, and then you can open FormIt and import the OBJ file into FormIt. And it's a great way to continue modeling in FormIt. Let's say if you started in Tinkercad, or maybe you like Tinkercad, but you want to give yourself a new challenge, try something different and try a different software. So yeah, definitely consider bringing your existing model into FormIt, and you can use all of the tools I'll show you in a second. Okay, so I'm going to share my screen now. Okay, so you should be able to see my FormIt screen up here. And before I jump into it, I want to mention that, well, this building may look kind of familiar to you because I used it as an example when I did some modeling in FormIt in the first webinar, which was on, I think it was on December 3rd. And I know that we have links to those previous webinars. So if you're interested in learning more about FormIt, but you might have missed the first webinar, definitely go back and watch that and learn how I did a lot of the modeling already in this example. And so since then, I added a little bit more detail here. I've added some more outdoor designs. I've added some trees and some landscaping. I actually, I had a preview of Zakia's, her presentation a couple days ago. So I added a small living wall here, which I think is such a wonderful idea. And and I just modeled that again in FormIt. And so I wanted to show that off as well. Great inspiration there. So I want to talk first about environmental analysis in FormIt, and then I'll move on to computational design. So in the last, say, 10 to 20 years, I'd say people and governments have become much more aware of energy use and its effect on climate change and global warming. Buildings use a lot of electricity, gas, they use a lot of materials, and they also create a lot of waste when they're demolished. So as engineers, builders, and architects, we try to design and build with less negative impact on the world to help reduce the effects of we're seeing on climate change and global warming. So many countries now have guidelines around energy use intensity or the cost of energy of a building. And as designers and engineers, we need tools to help us know if we're meeting those goals or meeting those guidelines. So there are three ways in that modeling in FormIt can help inform the designer so he or she can make better decisions with respect to sustainable design. And those three tools in FormIt that I'll show you are shadow studies, solar analysis, and then the insight energy analysis tool. So first I'm going to show you some shadow studies inside of FormIt, and you'll see if you'll see in this view, you'll see I do have shadows turned on here. And the first thing that you always want to do in FormIt is set a location. So if I go here to the properties panel on the far right, you'll see that I already have an address set in here. And if you don't already have an address, you can go to this location button on the ribbon up here, and this will open up and you'll be able to enter a location in the upper left. So I was playing around with this earlier and it seems to be hanging on me, but this would normally be a map, and you can enter an address and you can zoom in on a specific area and pick that as your location. And that location is important because the shadows that you're seeing in the solar analysis I'll show next, they're all based exactly on that like geographic location anywhere in the world that you've chosen. And those shadows, right, they differ whether you're, say, close to the equator or close to the North Pole. Everything's very, very different climates. So looking at shadow studies first, something that I have here is, so I have this outdoor track as an example, and I've created another option for the outdoor track. And what I'm doing here is just turning on and off some different layers inside of FormIt to show you this other option. So I have an option of a track that's more in front of the building. And let's say maybe it's important to me, since this model happens to be located in Boston, and I want to be able to use the track, you know, most of the year, even though there is snow in the winter in Boston. Maybe I want it to be less in shade and more in the sun, so that in the winter time, it's a little bit, there's less ice on there and it's a little bit more palatable for the winter. So here I can go up in this little sun tool here. I have shadows checked on. I can also turn on this sun editor. And what I can also do here is adjust the day of the year. So I can go in here, let's say, so today is February 25th. So I'm going to type in February 25th. And what I'm going to see is the exact day and what the shadows are on today. So now I have this, you can see the red lines, the circle here, and it's showing me the path of the sun. So I can grab that sun and drag it along this side, and you'll see that those shadows are changing location. It's a little sluggish here as I am in the Zoom meeting. You can see sort of later in the day, there's a lot of shadow across that track. So that might not be the best option for me. So what I might do is go back and switch over to my other option for my track and see it's getting a lot more sunlight, and that's important to me. Another great example of why I might want to do a shadow study is, again, zooming in and looking at maybe the living wall I have here or the planters I have to understand, well, is this area mostly in shade all day long, or is this area mostly in the sun? Because that's going to, as Zakia mentioned, that's going to have a lot to do with what type of planting I need to pick for that location in order for it to thrive and grow in that location. And the final thing I wanted to say about the shadow studies is I can also use it to investigate and sort of design the interior spaces of my building. So this is an example of an interior shot of the building, and I'm going to go back into that sun. I'm going to keep shadows. I'm going to turn the sun editor off though, and I'm going to just look at, you can see how I have the shadow of the sun in here, and I can just sort of grab this timeline and sort of see how that changes over the day. Maybe there are a lot of long shadows in here. That might be a good thing for this space, or it might be a bad thing for this space, right? Depending on what the space is used for. So again, that's just one example of how you can do some environmental analysis inside of FormIt. The next thing I'm going to show you is what's called the solar study, and this is about the sun and the strength of the sun and how much solar heat gain you're getting into your building, right? Because the sun's a powerful source of heat and light, and that can be a good thing and that can be a bad thing, right? It provides lots of free energy, but if it's not controlled, it can cause too much heat gain, which would mean that you would need more energy to cool a space with air conditioning. So I'm going to investigate this facade of my building, and I'm going to do that because I know this is the south facade. You can see this north arrow in the bottom left here, and that's showing me that this side of my building is facing south, and that's going to, at least in the northern hemisphere where I am, that's where it gets a lot of heat gain. So to start off a solar analysis, I'm going to go back to that same sun button and click on solar analysis, and that's going to open up a dialog that will allow me to pick some faces. So now I can just click, and I'm going to pick both the glass face and the brick face of this building and click on Analyze. And this is going to take just a few seconds. And what this is going to do is show me with this key at the bottom, the sort of the solar heat gain on that face. So you can see it's sort of in the middle range, right? It's not a small amount of heat gain. It's not drastic either, but maybe, it's a good amount. I have a lot of glass on this facade and there's a lot of heat gain coming in. So what I might want to do, I'm going to click out of that for a second. And I've already created some louvers or panels that are going to help shade that glazing. And I'm going to turn that design option on here. And then I'll go back into that solar analysis dialog and I'm going to pick those same faces again and analyze and see what the impact of adding, some kind of louvers to my building might be. And so you can see that now it's showing me that the sun is less strong here, right? It used to be something like a measure of like 135, and now it's down to say 59 or 60. And you can see that makes a really big impact on the amount of sun coming into my building. And that's something it's great that I can find that out early on in my design process when it's really easy to make changes. It doesn't cost anything to make changes. I don't want to find that out later on when I've built the building and realize now I need to add to it. So that's a little example there of solar analysis studies inside of FormIt. And the third thing I'm going to show you is a way to use a another Autodesk tool called Insight Energy Analysis, which sends my model up to the cloud. It analyzes it and gives me some feedback on energy use of the building. And to do that, I set up my model with a few things. I need that location set, which I mentioned earlier. I also need to have some levels in my building set. So you'll see those blue lines here are indicating some levels in my building, and I've set my geometry to use levels depending on the height of these different buildings. So I have levels set, I have solid geometry, and I have a location set. And then I click on this next button over and I can generate insight. And what that will do, I'll click that button. I've already kicked it off and started it, so I'm not going to do that here. It might take, say, like, it might take 10 or 15 minutes, and then you'll get an email response back telling you, oh, your insight's ready, go and check it out. And also, once it's ready, you can go back here and click on View Insight, and that will take you directly to the website that I have pulled up here. And here I'm also logged in. I'll point out in the upper right here. I am logged in with my Autodesk ID, and that's how it knows that I'm the one who sent that Insight Energy Analysis up to the cloud. So within here, I can choose from the settings. I can choose between imperial, which in the United States we use feet and inches. Lots of other places definitely don't use that. So you can switch to metric when you need to. And you can choose to see the cost as an annual cost or energy use intensity. I can also choose the currency, like I'm set to US dollars here, but I can choose lots of other currencies. And I can also, if I know specifically, I could add the specific electricity rate and gas rate for my city or town. I'm just going to leave those. I leave those as default generally. And then what I'm going to do is click on this. These are various Insight Energy analyses I've done in the past. And I'm going to click on this second one here. And you'll see that this is the model that I was just showing you inside of FormIt. And in the upper left here, I have this number 3.8. And what that is it's telling me it's $3.28 per square foot to run this building, the energy use of this building over a year. And by itself, that may not mean much, but I have some benchmarks here of a ASHRAE 90.1. And that's a company that it designates energy standards for buildings in the United States, and it's giving a benchmark there. I also have there's an Architecture 2030 challenge, which is about getting buildings more sustainable as we move towards the year 2030. And it's showing me sort of where I am on that spectrum. So if I scroll down, I see different cards here that are kind of different ways I can affect the energy use of my building. So right now it's $3.28. Well, if I look at for example, the operating schedule, that means like, is this building open 24 hours a day, 7 days a week? Maybe it's not. Maybe I know that it's only going to be open on weekdays, so Monday through Friday, and I don't really need to account for Saturday and Sunday. If I do that, you'll see that energy cost immediately goes way down. And you can, again, explore the different cards here and understand, like, well, if I change the roof construction, how does that affect my building? Or the wall construction, or daylight and occupancy control. So you can play around with that. So that's sort of the three ways inside of FormIt that I can start to look at environmental analysis again. So shadow studies, solar analysis, and then insight energy analysis. And by the way, I know I'm going fast. We are going to give you like lots of links at the end, and you can go back and you can explore this on your own as well. So now I'm going to switch and talk a little bit more about computational design in FormIt. And so FormIt uses it's called Dynamo, and Dynamo is a visual programming language that's available as an add-in with FormIt, and it allows you to use computational design to add details to your model. There are certain modeling capabilities that computers are really good at, like dividing a surface into small equal pieces, or calculating like how many 5-inch tall steps I need in my staircase to go up 12 feet or something like that. And this is available for you as a designer, so you could take advantage of a computer's capabilities to generate faster, more accurate designs. You could learn visual scripting in Dynamo to create these more custom workflows, but you can also use sample scripts that come for free within FormIt. And I'm going to show you a couple of those sample scripts today. Before I show you, well, I'll show you the sample script first, and then I'll show you how it works inside of FormIt. I'm going to show you how to do a stair, actually, which a little similar to what Kellyanne showed inside of Tinkercad. We'll do a stair using computational design. What I'm first going to show you is this. So this is a Dynamo visual scripting. So it's a lot like the code blocks that Kellyanne was showing. Like each of these little things you could consider as a code block, and you string them all together with these wires. Right, I can grab this wire and I put it on another code block, and that's how I start to create my my stair using computational design. And I want to point out a few. These are called like parameters here, like the stair width. I think Kellyanne had a variable for stair width as well. I could change the riser height. I can change the landings. Do I want a middle landing? If I do, how long is it? And that kind of thing. And so it can get pretty complicated pretty quickly, but we're gonna, if you're interested in and want to dig in farther, we can give you tools to do that. So the final sort of node you always need is this bake to FormIt node, which sends that geometry back to FormIt. So what I'm going to do now is go to, in FormIt, I'm going to go to this Dynamo tab here. And within the Dynamo tab, you see these are already samples that are set up for you to use. So I'll click on this stair sample. And I'm going to drag the stair over here, and I can click the space bar and sort of change it 90 degrees if I want. So obviously right now this stair is way too big for my site, but I can just click to place it. But now you'll see on the far right here, I have various parameters, and I happen to already know that the height I want to go up is just 4 feet. So I'm going to change that floor to floor height to 4 feet. Maybe I'll change the stair width to 7.5 feet, and I'll click run, and that's going to rerun that script just the way Kellyanne was clicking play, and it's going to edit it and change it in my model so that it fits here. And it's still very tall, which is kind of odd, but so what I can do is continue to adjust it. Like she says, sometimes you have to you have to change variables, and you have to play around with it and see what fits. And eventually what you'll end up with is a stair that nicely fits in the space. If I select that guy, I'm going to actually delete this one and show you my final rendition of a stair on a different layer, which is right there. So I got it nicely to fit there. I got rid of an extra landing. I changed the width of the stair, and it fits nicely right there. The other thing I want to show you is the idea of a ramp, right? So we talked about the importance of a building being accessible to everyone. And there's another Dynamo script here that if I click on that, you'll see I get a ramp here. And I think I can already tell this one's also going to be kind of weirdly scaled, but we'll just see what happens here. So I place it, it's okay, it's really big now. So I place it, and then I can see these parameters on the side here. And I'm going to change sort of the floor to floor height. I will say, does there need to be a middle landing? Maybe I'll say, no, there doesn't need to be a middle landing. I can check the rise and the run. So this means that for every like 1 foot I go up, I go over 12 feet. So, and that 1 to 12 is standard height for making a ramp accessible to people, to everyone. That's just a standard height. You don't have to pick that one, but it's an option. And then again, I just rerun that graph again. And it will take a second because it's going back into that Dynamo script, right? And it's going through each piece and it's rerunning the script. And then what it's going to do is finish and show me this finished ramp. And again, I'm not quite sure why it's not functioning exactly as I'm expecting, but again, I can sort of move it around and I can get it in a better location. Let's see, go back here. Maybe it's just the width. So maybe the width is really huge here. Anyway, again, so I'd have to go play around a little bit and I can get a nice, another sort of computational design method for creating stairs and ramps at my building. I'll just point out really briefly, but I won't go over it. But like, so if I select, for example, this what it's called like a curtain wall. So there's this big swath of glazing here, but within the glazing, we obviously have little individual pieces. So we have the glazing's been broken up and divided into many little smaller pieces. And that again is also a Dynamo script. And I can tell that because when I select it and I look at the properties, I see these variables. And I also have this button that says edit embedded graph. And that's how I know it's coming from Dynamo. So there's a lot of exciting things you can do with visual scripting inside of FormIt. So definitely, check it out. And I will hand it back to Kellyanne. And just to remind you guys, there will be resources for lots of links to things so you can go back and learn these things in more detail in a little bit. So thanks.
Awesome, Heather. Thank you so much. And yeah, so when you get your email, it'll probably be by Sunday night. I have it scheduled for Friday right now, which is tomorrow. But when you get your email, you'll get an email with the slideshow and also, the link to the resources, which is also actually on the contest page as well. So plenty of resources for you. And also we have resources from Autocad as well, which is up next. But before we do that, this is my quick hand raising question. So we talked a lot about collaborating with automated processes in order to make things. Raise your hand if you agree with this statement. So collaborating with automated processes can help us be even more creative. Jenny, how are we doing just percentage wise? Was it about half of the people raising?
It's growing. It's not quite half yet, but
close to half. Oh, so now we got more.
Yeah.
These are my favorite ones because everything kind of pops up on the screen and you can see it in real time.
Mm-hmm.
What's our final tabulation, Jenny?
I would say we're at about 25%.
Wait, I saw Donald raised his
Or
hand.
no, hold on, 30%, 33.
Awesome, thank you, Jenny. So next we're gonna move into landscape design with AutoCAD, and this is with Dan. So Dan is up next.
Awesome, thanks, Kellyanne. So I'm gonna share my screen really briefly. Okay, here we go. All right, so looking forward to talking to you all a little bit more about AutoCAD. So in order to understand where AutoCAD comes from, you have to understand where we've been. So why am I showing you this strange old antique photo from the 1800s? Well, what people are doing there is what people do in AutoCAD today. They're drafting, they're drawing a building out manually with pencils and paper. And this process continued on well into the 20th century. So you have this kind of Mad Men era looking scene, but you see all these people leaning over these giant drawings and they're creating blueprints, which I'm sure is something that a lot of you have heard of before. So in 1983, AutoCAD comes onto the scene and is the first commercially available software that takes this manual drafting process of actually designing a building and brings it onto the computer. And in its first iteration, this is one of the very first AutoCAD drawings. This is a space shuttle. This is actually a drawing of the Space Shuttle Challenger. So this is what AutoCAD originally looked like. But over 40 years, we've evolved a lot. And now you can see we've come a long way. So this is another space shuttle, but in AutoCAD today. This is actually, I took this in my instance of AutoCAD. So it's been a very exciting trip, and it's enabled workspaces to go from looking like this to modern workspaces like this. And if you actually zoom in, you'll see that these people here are using AutoCAD. So I want to just make sure that we're all on the same page about how AutoCAD fits into the construction process. So this is a very, very, very basic, abstracted, high-level view of how a building comes to be. And I know there's a lot of steps being left out here, but in a simple way, things go from being designed in AutoCAD, as you see all the way on the left, and then drawings are created. And the purpose of these drawings is to tell the contractor or builder what you want to build. and they take these drawings and then they use them to build a building like you see on your right. So AutoCAD exists today in 3 different platforms. You have AutoCAD Desktop, which is the classic that a lot of you are probably familiar with. And then there's the AutoCAD Web App, and there's the AutoCAD Mobile App. And today we'll be focusing on how you can use the AutoCAD Web App. And quickly before I do that, one thing I want to explain is this concept of a drawing type called DWG. So in order for AutoCAD to open a file, it has to be in a DWG format. It's .dwg. And DWG obviously stands for drawing. But what that means is we're going to have to convert your FormIt model into a form that AutoCAD can use. So this is the model that Heather was showing you before. And what you'll do is in FormIt, you'll select the components that you want to turn into an AutoCAD drawing. And you'll see that I deselected the trees because I don't want to import those. And then I go to export and I go locally. I want to save it locally. And then I want to make sure that DWG is selected. And then you'll see that I clicked selected only. That's telling it I only want those elements that I've selected to turn into an AutoCAD DWG drawing. Hit export, name it anything you want, and there you go. So then you'll be able to use the AutoCAD Web App. So you'll go to web.autocad.com, and if you don't have an account already, you can create a free account. I'm not going to walk through all the steps of how you would do that, but when you receive the resources folder, you'll see in the AutoCAD resources section that there's a PDF for how you can create a free account for the AutoCAD Web App using your edu email address. So once you're inside the AutoCAD Web App, you'll see this page. And so if you want to create a new drawing, you hit New Drawing and you give it any name that you want. And then you choose your drawing units. And as Heather was explaining, you can choose metric or imperial. Metric is centimeters and meters, commonly used outside the United States. But here we use imperial, that's inches and feet. So I'll go ahead and hit imperial. And then I will open that drawing. And here you see the AutoCAD canvas. And for anybody that's used AutoCAD Desktop, you'll notice this looks very familiar. I always go and change the settings and the units to make sure that we're looking at architectural units. And what that allows me to do is when I'm typing a dimension, I can use apostrophe to indicate feet as opposed to having to use a decimal point. So there's 2 ways of executing command in AutoCAD. You can type in a command, which is what I've just done here. I typed line, and that creates a line. And I'm going to make a 5-foot line. I do that little apostrophe, and boom, there's my 5-foot line. I can also use a command called polyline, which come up in 1 second. But I can also access all of these commands down at the bottom left in this ribbon. And so this is you can type these commands or you can select them here. So there you see the line command right there. I select it and create a 50-foot line. There you go. So you can also, as I was saying, use a command called polyline, which you'll have to type p-line in order to use. And what this does is it creates a series of connected lines all together. So I'm going to draw a rectangle here. And this then becomes one unit, one connected box, as opposed to 4 individual lines. And there's a lot more you can do in AutoCAD, obviously, and really the best way to get to know AutoCAD better is to just jump in and say, I'm going to draw a house today, and you'll start to learn and get the feel of the program. So that's how you create a new drawing. What I also want to show you is when you log on to the AutoCAD Web App, you'll see this folder called Samples, where we have a bunch of samples already ready to go that you can use and play with. So I just opened the Villa project sample, which is an example plan of a house. And you'll see generally what a plan of a house looks like in AutoCAD. This is before it becomes that drawing that I was talking about before. And there's some trees that you can use for your landscape plan there, but I also have some that you can use later that I'll show you. So in addition, you can upload an existing file from your computer that, so for example, like the drawing that we exported from FormIt. So there's that drawing, and I would just click it and it brings it straight into the Autocad Web App. After which, when you click that, you'll end up with your drawing inside the web app. Now, when you bring something in from FormIt, it's going to be in a form called a block. That means everything is bound and tied together. So what you'll have to do is you'll have to type explode, select your objects and type explode, sometimes 4 or 5 times to capture all of the drawings. Fortunately, I have already put in the AutoCAD resources folder that you'll receive a cleaned up drawing that you can use ready to go with some plant blocks, as we call them, for you to use. You'll see down there, there's some trees, different looking trees, some bushes that you can use. And what you want to do is just take those and start. You don't want to use those individual instances, but you're going to want to type copy or move and copy the plants into your drawing. So some of the things you might want to think about as you're starting to play with this concept is where you like to see plants as you move around a building. You know, most people like to have plants adjacent to pathways or entrances. In school, you know, one thing that I like to play with is if you have a hard edge of the building, what does it mean then if you put a tree next to the hard edge? So here you can see that I'm adding some more bushes around the side. But yeah, you can add a tree to a corner. I think that adding a tree, which is such a soft, different element to the hard edge of the building, actually makes that hard edge of the building stand out a little bit more and makes your building that much more expressive. But it also can soften edges and can create more pleasant experiences. So here I've taken one of the trees, I've put it in that little corner, and then I'm going to copy that tree and put it in another location. But what you also want to make sure you do, you don't just want to take this tree and stamp it around. No 2 trees are the same size. So you can take that tree and then place it where you want it. And then you can type scale. So once it's there, you type scale, you press enter, you select a base point, and I'm going to scale it by 2 or 1.5 in this case. So it's using that same element, but making it larger. And so that's really just the very basics, just very much scratching the surface of AutoCAD. But I hope you guys enjoy using it for this contest. Thanks so much.
That was awesome, Dan. I feel like, because you were an architect as well, right before you joined Autodesk, I just feel like architects should have I had like a Bob Ross moment with both of you guys when you were, I feel like there should be a TV show where architects just talk about architecture because it's so enjoyable. So thank you so much.
Thank you.
And students are getting a world-class education here as well. And we're about to talk about how that relates to the contest as well. So having product managers from both AutoCAD and from FormIt to share the mastery. I don't know why this keeps starting from the beginning when I do that. So there we go. So I am just moving to, okay. So here's my next esoteric question before we move on to the next segment. So this was, I just was thinking about having been a former English teacher and metaphors. So when we think about landscape and we think about the modern city, raise your hand if you agree with this statement. So the landscape is the glue of the modern city, or if you're feeling super creative and want to talk to Jenny in the Q&A, you can fill in the blank. Maybe you have a better metaphor or better idea. So landscape is the blank of the modern city. So raise your hand if you agree with this statement or fill in the blank using the Q&A. How are we doing, Jenny?
Canvas of the city, the modern city, the breadth.
What was the second one? I didn't hear it.
The breadth or the canvas.
Ooh, the breadth. I like
the pearl.
The pearl. Oh, you all are like poets and architects and engineers.
Here's a good one. The cloak of the modern city. I like that one.
Cloak of the modern city.
Yeah.
Beautiful. All right. Any more, Jenny?
Heart.
The heart.
Mm-hmm.
I agree. I love trees. All right, so let's move on. So last but not least, so make it big. So this is the second contest. This is the official announcement. So you've stuck around to the end to hear about the official announcement of the Make It Real Student Design Challenge #2. So this can be found at autodesk.com. Autodesk Make It Real. If you did participate in the first competition or visited the first page, you might have to refresh your browser to use this URL. But you can also find it on the Instructables contest page as well. But autodesk.com/Autodesk Make It Real. So again, this challenge is to use an engineering mindset and computational thinking to help James make his vision work for the environment, the surrounding community, and for people with disabilities. The end product should present a clear visual depiction of the design while also providing analysis about how you have addressed issues of access, inclusion, and environmental sustainability. If you completed the first challenge, this is your opportunity to revise it. Even if you won, you can still make your design even better. And also just thinking about this new problem that James has introduced to us. So again, if you completed the first challenge, you may revise, refine, and build upon your original design idea. Maybe you began in Tinkercad and you want to bring it into FormIt, for example, and then from FormIt into Autocad, which would be super cool. But you're not required. So if you didn't participate in the first challenge, don't worry about it. You got a clean canvas and a fresh start to do so. So you're not required to have participated in the first challenge to participate in this one. So you're going to do it in the form of an Instructable. That was sort of what James showed you earlier. So your entry might look similar to some of the entries that James showed earlier. So your Instructable needs to include images, text, and documentation. Design should be created using an Autodesk product such as Tinkercad, Fusion 360, FormIt, Autocad, and or Revit. I know some schools also use Revit as well. So again, this is at the bottom of the first contest page. You can see all of the winners, and that's linked to the new contest page. So if you're curious, like what is an Instructable? The contest is hosted on Instructables, which is a really fun website that you can also explore in order to find really cool do-it-yourself projects, from baking the best chocolate chip cookies to building a cool lamp and wiring it. So there's all types of fun projects on Instructables, including these entries for the contest. So please, if you're new to this, you might want to explore the winning entries for inspiration from the last contest. So judging criteria, so technical skills. So how well does the student product demonstrate 3D digital literacy, which is kind of what we were trying to demonstrate through our demonstrations earlier. Engineering mindset. So thinking about that graphic that I showed earlier from the Royal Academy of Engineers in the UK. So how are you showing that you're visualizing, improving, using systems thinking? I'm even thinking back to some of those cool graphics that Zakia showed earlier from EcoRise of the different systems, like the irrigation system, for example, in the living wall. Adapting, problem finding, and also creative problem solving. And you all are creative problem solvers, we can tell already. So also, how are you using computational thinking to solve the problem? So you could do so maybe by using Tinkercad Codeblocks and designing a ramp or a different set of stairs, or even something new that we haven't considered. Or you could even use those scripts in Dynamo, or the Dynamo scripts that Heather showed you in her demonstration. And lastly, presentation. So how compelling does the student product tell a story that is relevant to James's vision? So really also taking into account James as your client and really listening. You might even re-listen to the recording of James talking about his vision from earlier. So the rules, so this is very exciting. So this competition is open internationally. We had a lot of international interest for the last competition, but the last one was only open to the US and Canada. So this time it is open internationally. There is an asterisk, so you need to actually check the rules to just make sure that where you live is eligible. But it is an international contest. It's open, it starts tomorrow. And it will last until the deadline is April 1st. There will be 13 prizes awarded, 3 grand prizes. So the 3 grand prizes are each a $500 gift card for each winning student product. And 10 runners up will receive an awesome bag of exciting swag from different parts of the Autodesk family, including Instructables. In thinking about what can you get with your $500 gift card from CDW, CDW created this cool prize gallery for us to give you an idea of some of the things that you could get with $500 from CDW, because I know students may not be as familiar with CDW as it is a office supply for the most part store that we use at Autodesk and other companies use. So they put out there that you could get a 3D printer, you could get an iPad, but also bundle it with the pen and the cover. You could get a Lenovo ThinkPad. You could also get that one at the bottom is actually a VR headset. So these, and some of these are actually worth more than $500 as well. So you can choose one of these prizes, or you could choose the $500 gift card. So the schedule for the webinar, I said that, we're halfway through it now, which is really exciting. We will have another webinar in March that is meant for you to be able to, as you are engaged in this design challenge, it has an engineering nature to it. So we are going to pull together a panel of engineers similar to the architecture panel that we pulled together the last time, so that you can ask questions to engineers as you're working on towards making that April 1st deadline. In April, we're going to have another webinar that is going to be introducing a new design challenge, which is the third design challenge of this series. And then in May, we'll have a similar kind of panel, and it'll be focused on the construction industry. So if you've missed the first 2 episodes, you can go back. They're on the Autodesk Education YouTube channel. So you can see episodes 1 and episode 2, and episode 3 should be, up there, I would say by Monday at the latest. And lastly, if you're looking for mentorship, if you are in the United States, you should check to see if there is an ACE Mentor program affiliate where you're living. Because the ACE Mentor program provides mentorship for students your age who are interested in architecture, engineering, and construction. Paulette, who's the director of the West for the ACE Mentor program, has offered her, her contact information here on this slide. So if you're interested in joining the ACE Mentor program, we encourage you to do so. And that's it. So we thank you for sticking with us throughout this episode. We are so excited to see what you make for the design challenge. And before we sign off for the evening, Jenny, are there any burning questions from participants?
I'm not seeing any additional questions that come in.
Awesome. So we are here if you need us. We are so excited to see what you make. James, do you have any final words before we sign off?
No, but thank you for everyone for tuning in tonight. Like I've said a few times, and I'm really looking forward to seeing some new innovative ideas, and I'm really just happy to be a part of this. So thank you for your time.
Awesome. Thanks, James. We're happy to have you with us. I also want to thank our Autodesk family for sticking around and helping throughout, and also just our special guest, Akia from EcoRise. We are so happy that you joined us tonight and you provided us with so much inspiration and thinking about how we can apply both engineering mindset and also thinking about sustainability to this challenge. So I know it's getting late for those of you, particularly on the East Coast where we are, or where I am. So if there are no other questions, I think we're going to sign off, and we hope that you join us for the contest and join us for the next webinar in March. Right, take care, everyone. Thank you. Good night.